because we have the trains that drop off, and then we have, people from the South Bay and all. Arnab, nice to meet you. Thanks for speaking. Of course. I did. We didn't do Oh, it was.
I'm gonna go put that somewhere else.
We had 250.
Sorry?
And the 251 was a name. Ready for us to. Well, you can't number.
Just a minute.
People again or not?
Okay. Yeah, so I'll give it over. Right application.
Okay,
Pizza and being out for like an hour.
whatever they want. I'll tell them the pizza's there.
You weren't that bad.
All 11 feet. They're usually like half.
High facts.
Yeah, right here.
You can do there.
So the other thing which I have to tell, stating is that, I went to have women and that my home, I'm like, oh, we'll do it at our office. Tell her that. So Kyle had me reach out to a gal from CBS. She happened to see the hackathon and she was like, oh, this is great. So I started chatting with her. And like, we're now Exactly. We'll do it again. I already told them I'm gonna do it again. And then you want to do the content?
I scuba dive, that's what I thought. Oh, this is like a pattern.
Yeah.
Okay, perfect, awesome, thank you.
Oh,
Yeah, they'll stand.
a really good turnout. Hmm. Hi, how you doing? So yeah, feel free, take home some Milvus stickers.
Exactly. So we don't get too bored. These are very cool.
Thank you.
Scientists.
Who
We have
did,
a designer.
Yeah.
They designed it, yeah.
Yeah, it's pretty. Have a name. Pretty good.
Milvus. Yeah.
so it's I think a species of hawk.
Yeah, I think so.
Oh yeah.
Oh, yeah. Pretty cool. Thank you.
Yeah, of course.
Hmm. Ooh. is.
Tags.
I guess that, yeah.
There are no other opportunities.
Well, so you'll get like one of these security badges. So you can write your name on that.
Yeah, I guess they don't need these, but it's okay.
It's okay. You can double up if you want. Yeah. Hi, how's it going? Hi. Help yourself to some swag while you're waiting. Pass the time. Hmm. I think you'll actually you'll be able to write it on your. Hi, how's it going?
I'm then looking forward. What do I kind of scan myself and show that over register?
Yeah, so yeah, it's just for like security, they'll give you a badge and
Yeah, that's good.
feel good.
That's negative.
All right.
Go for it. That's what they're there for.
I think everyone's going for pizza when they.
Ah, okay.
Yeah, that's why no
Okay.
one's come here yet.
Yeah, yeah.
Perfect.
Ooh.
I have Bedrock stickers I can add there if you want. You can keep it on this side. Fine.
I think you're welcome to. Yeah, no.
What I-
You guys, I guess, you know, like you're
Yeah.
sort of joint hosts.
Hey,
Add some Bedrock stickers. If it's easy.
What I'll do is during the talk, I'll promise Bedrock stickers to anyone who asks a good question.
Yeah. They'll have to be paying extra special attention to earn it. Hmm.
Last week.
Good question.
I'm gonna fill fast. Hi, welcome.
Can I connect it one?
Yeah, go for it. Go for it. Please do. I think it's on. I won't say any naughty words.
Do you mind if we do a tech check to make sure that I can get through to presentation or?
Yeah, sure. So I think one difficulty I found is I'm sort of extending the screen.
Yeah.
But then you don't have a convenient way of like seeing what you're doing.
Oh, yeah.
So okay. And
I just want to make sure that the way you prepared works well. So,
Yeah.
Let me join the.
we're actually streaming
Oh, you're streaming
now, so it's up to you. Like you're very welcome to. Do you want to?
It's okay, I'll just do it.
Yeah, sure.
Quick check.
Yep. Okay.
Hey,
I'm gonna-
if anyone complains, tell them it's my fault. So I connect to Zoom.
Yep, you connect to Zoom. And
And then. Oh no, I don't want to have it put here.
actually,
I'm on Zoom.
I think I need. Hang on. So you're on Zoom. Are you sharing your screen?
Not yet. You want me to share?
Yes, please. Yeah.
Cool. Share that screen.
I think I actually need to send this to the other.
Here I'm sharing my screen. I don't need to fill it.
Need to get this across to the other. Geez.
Oh, cool. Yeah, I saw it. Right. Here. And perfect. And if I do that, you see it. Okay, perfect. Stop share. I'm good.
Awesome. Yeah. thanks.
I can. Do I
Um,
leave the Zoom and join back?
yeah, I think you might actually, looks like you're still,
Yeah, I'm still here. I
could you leave the
Yep.
Zoom? Yep.
I did. Perfect. There's still. Thanks. I just want to make sure that we were deck ready. We're good. So
Yep.
we'll wait for you to go. We have everything ready.
Mhm.
I have everything in disconnected mode in case anything goes wrong,
Mhm.
but it should be all fine.
Awesome. Well,
Thank
I
you.
guess we can relax a bit now. Yeah, I'll just remind you guys about these before.
Yeah, I'll do that. I'll probably put one of these on because always better not to have to have the mic in big things. By the way, excellent choice of speaker. I have the same.
Yeah, I think it's the top of the line Logitech.
Yeah. Awesome.
Especially if you get the sort of the special function working with the highlighter.
Yeah. I do the same. I'm not using it for these where I'm doing mostly demos because it doesn't make sense. But yeah.
I'm gonna get my water because for some reason, I feel like so many people. Hi, how's it going?
Yeah, so I'm the process. So
You know, this probably.
yeah, give it a strong. But yeah, thanks everyone. Thanks for coming. Like, looks like we have. Hey, we're gonna build some.
So, I mean, what is the company's called right now? Yeah. I'm really surprised.
Oh, that is before my time. Yeah.
And so at the back, I can write and I read the data on that.
Yeah.
As the internet.
Yeah.
So I have this idea of working with graphs. Why not make the graph controlling? Yeah. Okay, I mean, I could combine. On this,
Hey,
how are you?
have you met before?
Yeah, we met at when you get the talk about
On Monday.
Yeah. I was the guy who asked you about that.
Yeah.
Congrats again from the, I went back and the complex, I met Camille indeed, a very good guy, stuff, like, well.
Very hard to check.
I hope I will.
Thank you, right? Yeah, really focus on unstructured data, so that should be cool.
Yeah.
Yeah. And, yeah, we're a bit worried about it, so.
Oh, because I didn't reply to your
Oh,
email.
no, just the baby started pulling up so quickly.
Oh.
And after a while, like, yeah, we're gonna.
Oh, that's the case. Oh, I think of course.
Have you ever talked at the so?
I had a few hearts, yeah, so we both like our and it's a pretty common thing, so.
Yeah.
So yeah, I mean. Sorry.
In a nutshell, you just gotta connect to the Zoom link and share the screen. And so that would be, I'll have the Zoom window up by that.
Gotcha. Okay. And have you sent the link already?
Yes, it should be, yeah.
Okay. I'm just doing it same like
Yeah.
box, so.
That's right.
Um,
Yeah. Oh, yeah, sure. If you want to go to Fiverr, I've got some water bottles behind there. So the microphone feel like one button, it's can be separate from one. Yeah, we can't go straight. So I'll just put it out.
Yeah, and the one that broadcasting is that handheld?
Yeah, so I got a choice. You got handheld, but it's on trying to go to back.
Oh, what is that? You can type?
Yeah, in your hands.
Yeah.
Yeah, no, sure. Yeah, that's so, yeah, how long you guys like speak around?
Around the last 8 years now. The PromptQL startup, that's great for months. You get that data.
What do you want to? Oh, sorry, so we've got some video setups as well. What directions? I reckon single camera is perfectly fine, just like facing the podium. Thanks for coming. They might want you to sign in with.
Yeah, I was like, well, I just want to set up from now, like. Earlier.
Milvus is a database, this is the, right?
Yeah, so Milvus is a company who's offering Milvus. And then you have like a hosting service, which is still.
Okay.
So that's called Zilliz Cloud.
That makes sense, okay.
And I think we had to, like, I think at one point we had to rename the company because, we, fully open source Milvus straight into the foundation. So then it didn't have like a company name. But the idea is like, let's, like, you know, how people very much sort of like suggest like this massive scale of data. It's kind of like index search. So I guess like our sort of big like premise or vision is that similar thing needs to be done. And so, you know, it's going to be like this. Pieces of, yeah, chunks of information, and it needs some software that makes scales. And so that's where. Yeah. Yeah. No, it's available. Yeah, how about, geez, so how do you coordinate? Yeah, yeah.
Okay. Nope. There's the different words, one is the edge and the rest is outside. After means demons in, different demons. No, like background job.
Okay, yeah.
So in our first product, the background jobs were written in the Spanish code. So demons written Haskell, Haskell and Haskell are Haskell. Haskell was written in Haskell. Yeah, that's why it's a lambda for the Haskell and the demon.
Yeah, okay. I think it's good, like, I know, like, a lot of companies, like, the, you know, DeFi, or this is like paradigm of thinking startups, which I think is going to like, get out of the mall.
Yeah, but I talked about you make access data, right?
Yeah.
So what's the make access data? So
Maybe it should be complified. Quite serious machinery of that.
I want to get a good shot when people sit down, that's always.
Yeah.
Right, and people sit down, and then they're like, honestly, like, man, that's not great.
Since, yeah, just like. I'm starting to feel like. Yeah, I was just like, all right. Things actually work.
Gotcha, makes sense. But I remember I started even you used to be a researcher. What problem?
Yeah, I think it's just like,
Like, I used to be an engineer and researching, enjoy. And then I'm being product manager. Now I'm focusing on medium. So, you have to go and get my skill.
yeah. Yes, I have a 2 layer one, so change directions. So, I'm actually gonna start giving my creators lots of like some fun and games. Let me just see where things are.
I'm gonna go ahead. Or maybe I should sit in front, just heckle you.
Or encourage me.
Nobody wants to sit in front, sit in front. Yeah, 11 p.m.
Welcome in, everyone. Come in and take a seat.
They get the job done.
It was really cool. We had 1 what was hilarious is the last 2 oh my God. You should have come, but you registered too late.
We'll just wait a few minutes for everyone to get settled. Okay, so how about we get started? So thanks everyone for coming. This is a really great turnout. I think, yeah, we've reached sort of, I think we will reach full capacity when everyone comes into the room, which is really fantastic. So before we get started, I just wanted to give an introduction. So my name is Stefan, and I'm a developer advocate with Zilliz. And so you may know us as the company behind the open source vector database Milvus. And as a developer advocate, I'm working to help sort of like bridge this divide between, or this gap between developers and users. So I put up my LinkedIn, really love connecting with users, either current or prospective users of Milvus, find out like, what are you building? What sort of challenges are you facing? And really, enjoy helping people out. So do connect with me on LinkedIn and hopefully hear from you. Right. But I wanted to begin with a little sort of like fun quiz. It's like a little experiment I'm trying out. And so sort of like a trivia question. I think there'll be some prizes. We've got some swag to give out. So the first question is, what LLVM, so what large language vision model was released by DeepMind in December? And what are some of its capabilities? Has anyone come across this? No one wants to win any swag? It's really good swag, I promise.
Is it DeepSeek?
No, not DeepSeek. Sorry? V3? No. So, I mean, there's a possibility they've released multiple, that's a foundation model. Anushrut?
Imagine.
No. So all good guesses, but I guess no one gets the swag on this one.
Yes, here. Looks like large language, either video model or virtual model, or does that make sense?
Yeah. So it's an example of a large language vision model.
Acronyms now.
Yeah, I know. It's I think, yeah.
Oh, okay.
So I was actually referring to Harley Gemma 2. And what I really like about, what I thought was interesting about this model is that, so it has like your base version, your pre-trained version, but they've also got a fine-tuned version. So this is all fully open source, by the way. They have a fine-tuned version, which is fine-tuned to do a number of very specific language vision tasks. And so you can give it like different prompts to do different types of, things. It can do everything from captioning to OCR to segmenting. So here's just one example. So this is a 3 billion parameter fine-tuned model, which you can download from Hugging Face. And on the left-hand side is an input image, and the prompt is OCR. And then on the right-hand side, you can see, so this is the output in just like text. So this like 3 billion parameter model has been able to successfully perform OCR in the wild, but it can also do all of these other things. And I think this is sort of like a good example of these smaller models that we're seeing that are specialized to specific tasks and can do those really well. And check out the report if you're interested. You can Google that. Okay, so second question. So maybe a hint, everything's going to be related to like open source plus research. So what multimodal foundation model was released by Microsoft Research this week when I wrote that, which in the last couple of weeks? And what was it? How was it novel? Did anyone come across this? And they probably have released multiple models in the last 2 weeks. But I'm thinking about one in particular.
Is it some new version of Phi model?
No, good guess. So those are some of my favorite small models to work with locally.
Are these micro, are they copyrighted or is it just?
Well, so the models I'm talking about today, they're fully open source. They may have like restrictions on how you can use them, but you know, for research purposes, definitely. Like you can find out like the licenses on Hugging Face where you access the model.
Actually, this acronym is just for Microsoft, right?
Yeah.
Correct. Yeah. Okay. Did anyone see this this paper come out? I think I might have come across it on Hacker News, and I wanted to mention this because I think it's like a really interesting idea. It's a different type of foundation model. So it's a foundation model that inputs essentially images and controller instructions. So it does some things to like turn those into tokens, puts them through like a standard transformer architecture. But it's able to, so it's a foundation model because it has 1.6 billion parameters. It's trained on 7 human years of gameplay video data. And the model is able to sort of like synthesize future possibilities in a given point in this game. And like the idea is that creative people, creative types, they can use this as a tool to augment their own creativities. They can use it to sort of search different possibilities for gameplay in a way that is like consistent with the game. And yeah, I wanted to mention this one because firstly, I think it's really interesting, just like different foundation models with very unusual modalities. But also that I think it's really cool how we're thinking more and more about how we can use these models to augment not just productivity, but creativity as well. And so these models are sort of like augmenting human abilities rather than replacing them. So I guess no one wins no one wins any swag, but come and chat to us afterwards, and who knows, you might be lucky. And check out the paper. Okay, so I just realized I forgot to copy in my slide with the speakers for today. Yeah, so I wanted to, so I'll be talking first on Milvus 2.5 and its feature of lexical search. And then we've got Jean and Arnab from AWS Bedrock, who are going to be talking about some really cool features to extract structured data out of your unstructured data using the AWS Bedrock platform. And then we have Anushrut Gupta from Hazura talking about a really cool new technology, PromptQL. So sorry about that, guys. Okay, but onto my talk. So let's start off just by asking the question, what is semantic search and what is lexical search? Well, actually, before that, I think it's good to start with like the motivation. So Milvus 2.5 is the latest version of Milvus, our open source vector database. And released in December, it had like a really big new feature in that it incorporated a lexical search to augment the semantic search capability that was already there. But why would we do this exactly? Well, the motivation is, so lexical search has its advantages, semantic search has its advantages, they're sort of very complementary. So if you wanted to use both, you would actually need to work in two different databases or software. So you might go to, yeah, you know, who knows, I got an example there. But why not, you know, you should be able to do this within the same system. You should have like a complete system that can do both semantic and lexical search. Yes, yes, I am. Yeah, I was sort of debating like the order of the slides. So yeah, we're going to cover that. So let's start off with like what is semantic search, so we can sort of like just distinguish it from lexical search. And there's a really famous quote by a linguist, which is, "You shall know a word by the company it keeps." And that sort of like describes the idea behind these embeddings that are learnt via deep neural networks. So I've got an example here of very well-known model BERT for producing word embeddings. As input, it takes a sentence. Part of the sentence is then masked or hidden, and then the model has to learn to predict what word would fill the gap. And so it's using like the sort of like the company that the word keeps to build up a sense of its meaning. And so here's sort of like the paradigm you use when you're working with semantic search. You have your knowledge base, you then break it up into small pieces, put that through your deep neural network model. For example, it might be BERT. And then you get these vectors, which are the embeddings that capture the semantics of the input. And then you can use those to perform, you can put them into a vector database and perform a similarity search. So what that means is if you have like a query, you can then embed that and look for similar vectors in your vector database. And it turns out that so close in space means that there'll be close in meaning. So let's contrast that with lexical search. So I couldn't find any quotes, so I just kind of like made one up. So you shall know a word by its relative document frequencies. And so lexical search is about working with keywords directly. So imagine for each document, we treat it as just like a string of words. It's called the bag of words, and we count how many occurrences there are of each word. Then we can use that as like a representation of the document. And we can define some similarity measures on that. So this is sort of like in contrast to semantic search, which is based on the context that words occur. This is about, you know, like the exact frequencies of particular keywords. And so if you've been in information retrieval, you may have heard of the term frequency inverse document frequency metric. And so this is a way we can use those frequencies to measure the distance between documents. And in a nutshell, so it has two terms. The term frequency says how relative is this term in the document. So if that term is in the document many times, then it must be, you know, must be like very relevant. And then the second term says, what is the relative frequency of the term across documents? If the term occurs in every document, so say, you know, the word the will occur in every document if it's in English, then we would want you to discount those. And then we can sort of combine those two terms into like a sum, which will measure the similarity between a given document and a query. So you can see like these are two different ways of measuring similarity and sort of very like orthogonal and very complementary. So like what are some of the pros and cons of why you'd want to do lexical search or semantic search? Well, let's start off with semantic search. And so I've got an example here. Suppose you're searching for the keywords rising dough. Presumably, you'd also want web pages that contain proofing bread, because proofing bread, rising dough mean the same thing. To a lexical search algorithm, those are just like individual tokens. It doesn't know the relationship between them. But the semantic search, the model will have learned that proofing bread occurs in similar contexts to rising dough. So therefore, they're similar. So it's sort of like a more sort of, I guess, like a more flexible search. Whereas for lexical search, it treats each word as sort of like a one-hot vector, which actually might be what you want. Like maybe the specific keywords matter. If you're doing a search for holidays in Paris, presumably presumably you're not also interested in holidays in Rome or Italy or France. So you can see like there are cases where you can see that semantic search provides advantages, other cases where lexical search provides advantages. So why not combine the two in a single system? Okay, so I wanted to show you some results here just to kind of like demonstrate that there are advantages to combining lexical and semantic search. So we did an experiment where we took a data set of source code, I think it was from Anthropic. We built up, built up a vector database from that. And then we searched, we had some test queries. And then we measured how many relevant items were in the top 5 that were retrieved. And we used a number of different search methods to compare. So we tried full text search. So that's another word for lexical search, just by itself. We tried semantic search just by itself. And then we tried like a hybrid search that performs both and then combines the results in like an intelligent way to sort of combine the advantages of both methods. And then the very last item is hybrid search, but add stop word. So that's essentially just saying, let's do a lexical search, but we'll ignore really common words, the, are, and, into, that sort of thing. Those are obviously not keywords. So what you can see from these results is that, semantic search is doing a lot better than full text search by itself. But when you combine them, and especially when you're sort of like excluding really like non-informative words, then it can improve quite a lot over just a semantic search alone. So you can see there's like I think like a 4% difference there in the pass at 5. So in answer to the question, like which one should you choose? Well, both. They're really complementary and work well together. Okay, so maybe I should actually go back to the first slide now. And so that motivates having a system where we can combine both semantic search and lexical search, within the same API. So you can have all of your data in the one database, not have two systems running. And that's exactly what we did with Milvus 2.5. So let's go through how you actually use lexical search. Or maybe before we go on, is everyone clear at this point, like what lexical search is? Okay. So a few words about Milvus before we get going. So Milvus is the leading open source vector database, as measured by Docker pools and GitHub stars and a few other metrics. And what I love about Milvus, it's really easy to set up, has really good integration into all of the open source generative AI ecosystem. And it's really feature rich as well. Okay, so here's sort of like an image that's representing like the paradigm of lexical search. So we have our text data. We then, we have some data that we want to search over. Maybe it's like a set of, I don't know, internal company documents, whatever. The first step is we put that through an analyzer, and that works out what are the keywords and how often or how frequently do they occur. We can then put that through a function that turns that into a different type of embedding, a sparse embedding. Then the user comes along with their query. Their query again goes through the analyzer. And then we use a specific type of metric called BM25 to score the query against the collection and return the most relevant results. So the most relevant results are ones that have the largest overlap in keywords, taking into account that a keyword is more important if it's only in that document or less frequently occurring in the whole data set overall. So how do we actually use this new feature in Milvus 2.5? Well, it's very simple if you've used Milvus before, but if you haven't, don't worry, I'll sort of be going from scratch. So the first thing is you need to create the Milvus. So this is the Python SDK. We also have SDKs for Java, Go, Rust, etc. So we're in Python. We import the PyMilvus library, and we create this Milvus client object. And that gives us like a connection to the vector database. So like a relational database, the data has to have a schema. We have to sort of tell the software what will be the structure of the rows or the entries that we put in. So the first step is to create the schema. We're going to have 3 fields. We're going to have ID, text, and sparse. And we sort of, we specified their data types, maximum length, some other properties. The ID is the primary key, for example. And so this next step, this is something that you might not be familiar with if you sort of work with Milvus 2.4, but not 2.5. So we've got this new feature which allows you to make the output of what, so one field can be the output of some function on another field. And so in this case, so we have 2 fields, we've got text and sparse. What this says is the contents of the sparse field will be the output of applying this BM25 function to the text field. So this is like applying the the metric that we can use to measure similarity. Okay, and then so after we've created the schema, then we just create the search indexes. We create the collection. So a collection is essentially like a table in Milvus. And then we just insert our data. And you can notice that we don't have to call any neural network embedding functions because, well, there's none of that going on. We can put the text directly into the database with the insert, and it will know what to do. We've told it to use that BM25 function. And that's what you need to do. So after that, then you're ready to perform a lexical search. And you use essentially the same API as you would for semantic search, but with a few things changed. I won't go into the parameters, but we tell it what collection we want to search. We tell it what the query is, how many entries we want to return, and so on. And then it's going to return the closest entries. And that's it. So now you can do lexical search in the same environment that contains your vector database. You don't need to have any additional software. So what about hybrid search? How does hybrid search work? So hybrid search is where we do both a semantic search and a lexical search. And then we combine the results with some sort of a re-ranking method to hopefully improve upon the output, which we can then pass to our LLM if it's a RAG system or whatever. So this is just like a schematic of the basic flow. So it's very similar. We just have to do a few things differently. So firstly, we'll now create a separate field for our dense embedding. So we've got the dense field is for our neural network embedding, has a dimensionality 768. You can see how it's a different data type to the sparse. So it's a float vector as opposed to a sparse float vector. So we still need to define that function. So the sparse field will be the output of applying that function to the text field. And again, like we need to create the indices, but now we need a second index for the dense embedding. Then we can create the collection given the schema and the indexing method. And we can put this data in at the moment, you have to sort of like embed the text separately and then combine the text and the embedding into like this dictionary. So like one dictionary per row. And then you can just call client.insert and you put your data in and you're ready to do your search. So because this is a hybrid search, we actually need to call a different method and sort of like specify how the searches are to be performed in advance. And so we do that by creating these dictionaries of search parameters, sort of describing how the search should happen. So we've got one is like a query dense vector. That's going to be for our semantic search. The second one is for the sparse field with the BM25 metric. And then we instantiate this approximate nearest neighbor search request. And then we can put those two requests into a list and then pass them to this client.hybrid search. And so, you know, with just like sort of a few additional steps, now you're performing a hybrid search. You're able to combine the results of both types. You can see that we also have to pass it a ranker. And so that's like a specific object that has some formula that sort of like specifies exactly how you combine the results from the two. There's a few built into Milvus, a few common ones. You can also build them yourself. You can check out the details in the docs. And you know, once you've done that, then the results are same sort of format as they would be for either one separately. So just with like a few simple steps, you're now doing either lexical or hybrid search in the same system. So I think I'm running out of time, so I might just skip over this bit. I was going to go into a bit of technical detail here. Okay, so a few announcements before I finish up and hand over to the next speaker. So firstly is that, so suppose you're a Milvus user, you're having some trouble or maybe some challenges getting your system into production. So we actually offer like a video call office hours service. You can book I think it's like a 20-minute slot where you can meet with myself, a core engineer. You'll have the technical expertise to help overcome your deployment issues. So I think this is a really great resource. So really encourage, if you're like building something with Milvus, to take advantage of it. Another thing I wanted to mention is we've released a podcast. We sort of started a new podcast recently called the Unstructured Data Podcast. And the first 2 episodes are out. It's on Spotify, Apple Music, wherever you get your podcasts from. It's, I would say, sort of, more like sort of like casual, lighthearted banter, but, still like informative and educational too. So check it out. Good for listening to in the car on your way to work, that sort of thing. And one more thing to mention is, so the next event we'll be running will be more like a workshop. So this will be a workshop with Milvus, so us plus OpenAI. So it's on March 20 in Palo Alto, and the topic will be how to build agents. So this will be like a very hands-on, how do you actually build agents with our technology? So hope to see you there. I think it's gonna be really great. We've got like a really sort of core member from an important project. I have to keep it secret within OpenAI, but yeah, it should be really good. Okay, so that's it from me. I think because we've run out of time, if you have any questions, really happy to chat after the talks. There'll be like an hour for networking, and we'll actually have like a little booth set up for sort of like a type of office hours we'll be doing after this. So you can come over, we'll have a desk, and we can chat to you about Milvus and help you build your product. But with that, I wanted to hand over to Jean and Arnab. Do you guys want to come over? Thanks. Okay, this is the tricky bit. Oh, yep. So you take that one. Okay. Do you want the handheld microphone or?
I'll do.
Yeah. Okay.
I'll go through Madonna.
Yes, I can't actually see what I'm doing.
Where do you want to go? Okay.
Just give us a few moments. We'll get the tech set up.
Perfect. All right. Hello. Can you hear me? I got to turn it on.
Yeah, just press the button.
Okay. Good evening. Everybody can hear me? Yes, yes. Hello. Just to get started, just a show of hands of folks that are using AWS. I'd like to always see that. Pretty nice. Folks that are using Bedrock or even know what Bedrock is? Oh, wow. Okay. So Jean, that makes it easy. We don't have to give the spiel on Bedrock. But for those that don't know Bedrock, we'll just spend maybe 30 seconds on it. But with that, let me introduce myself. So I'm Arnab. I'm a solutions architect, almost 5 years at AWS. And I work primarily with customers like yourself that are building on AWS. Right now, I'm focused with a bunch of .ai startups. Hopefully, you'll be my customer one of these days. I'm excited. And with that, over to you, Jean.
Hey everyone, so my name is Jean Malha. I'm a generative AI specialist working here and helping startups innovate with Amazon Bedrock.
Perfect. Next slide, please. Okay. I don't want to kill anybody with slides. So even though we have an agenda, I'm going to run right through it and get to the demo. We are really builders. We are not salespeople. We like to show and tell. And that's really the objective we have, to talk about a cool new feature that Bedrock has launched. It's kind of in preview. Now, what is Bedrock? So Bedrock is our serverless platform for hosting large language models that you can consume with just an API call. You don't have to manage the infrastructure. You don't have to worry about which model. You just pick the API and you pay per use. So that's really what Bedrock in a nutshell is. And over time, listening to our customers like yourselves, we've added capabilities. And one of the capabilities that I'm excited to talk about today is Bedrock Data Automation. So we'll kind of talk about the pain point with unstructured data and then say how Bedrock Data Automation is solving it. And then I'll hand it over to Jean, who's made three demos for you guys. And we have only 20 minutes. So let's get excited, all right? Okay. Next slide. Okay. So the multimodal context, right? So, everybody knows that there's a proliferation of data from everything is smart nowadays, from your watch to your refrigerator, to an IoT sensor, to your car, everything is smart. So there is no end of data. And what we've seen with our customers, they say that they don't able to harness 80% of that data that they're collecting from us, from all these different gadgets. So, and one of the biggest challenge for that is because there's no constant tooling that you can use to extract information. They're in all proprietary formats. They have different schemas. So how do we solve this, right? So, I mean, folks that have used AWS probably know we've had some OCR kind of capabilities like TextRack. I call this TextRack on steroids, so that's what Bedrock Data Automation really solves, right? Yeah.
No.
All right. So Bedrock Data Automation is where TextRack kind of lets off. So what TextRack did was capture insights from different documents and images, and then really gives it to you in a JSON format or a fixed length string format, and then expects you to now build the full orchestration to a downstream system that can really leverage the insights. So we wanted to make that much more easier. So Bedrock Data Automation automates not only extracting insights from different multimodal constructs like images, videos, documents, and then also creates the workflow depending on your downstream system and integrates with that all over API. And you don't need to worry about which model to pick because we have figured out with all the work that we've done with our customers, what are the best models to choose based on the actual artifact that you're pointing Bedrock Data Automation to. Okay. So key features is that, everything is API driven at AWS. Folks that use AWS know this, but we also have a console for you to kind of get familiar with the UI and how to build this workflow out. So it's very intuitive. The underlying orchestration is completely automated for you. You pick your assets that you want Bedrock Data Automation to gather the insights, and then you push it out. A couple of additional things that we've added is, responsible AI and ethics and consideration, privacy, guardrails from, sensitive content that we don't want to expose. And so we have all of those prescriptive guidance already built in, and you have the option to configure that. Finally, it's again a simple inference API that you call in your workflow, and it does the magic for you. Excellent. Okay. So how does it work? So really, there are two basic output types: standard output. And standard output is really for known documents like your bank invoice statement, your driver's license, a typical claims form, a health ID card. So we've learned over the years what are those document types look like, or what do those images look like, and we automatically spit out the insights that we get from those. So that's what we call standard output. We support different modalities, as you can see. It's documents, images, videos, and audio, right? So out of the box, you don't even have to configure anything, just point it to your data set and it will do it. But we know that most enterprises, they have a lot of proprietary content, proprietary documents, proprietary fields, and we need to be able to convey that to these models that are supporting or powering Bedrock to understand those. And that's where custom output really comes in. So we call this a blueprint, but essentially it's basically a schema that talks about the type of asset it should look for and capture that and provide it in a format that is easily can be integrated to your downstream system. So like, for example, if I had a claims automation going on and you send in an images with your policy ID, Bedrock Data Automation can capture that information and catalog and create a case in your ServiceNow system. It can do that. I think we can jump into the use cases. Yeah. So these are the typical use cases that we see, and it spans many, many verticals. I just talked to you about claim related to intelligent document processing. It applies to financials. It applies to insurance. It applies to HR. There's so many different types. The next thing we see is media asset. Is a lot of media companies like Fox and CBS, they have so much media that they have. And how can they understand how can they group them together, bunch them together, and gather insights out of it? And finally, call center stuff like speech analytics is a key horizontal. I call it a horizontal because every industry wants to make sense of their support centers and how they're operating, and can they do the customer 360 across sales, operations, and billing, right? So one of the quick examples I'll give you is, say, God forbid, I get into a car accident, right? I get out of my car, I take some pictures of the damages, I upload it to my Geico insurance. I call the contact center and say, hey, I need this fixed ASAP. That's my only car. I got to pick up my kids. And I do all this stuff in one shot through an app that Geico provides me, for example, right? What the back office can do is different on the different modalities. The images that I uploaded of my car, the contact center conversation I had, and the back office policy that I am subscribed to, it can collate all that information and make it very easy for the claim handler to process that claim. It may be even like in the future with agentic world, maybe an agent will even approve that for me. So the possibilities are endless, So I just wanted to kind of paint the art of the vision, what is possible using Bedrock Data Automation. One of the key things that I missed talking about is everything that we extract, whether it's images, whether it's video, whether it's audio, whether it's document, we always provide a confidence score. So we can always bring a human in the loop if you feel that the confidence of extracting these insights doesn't meet your business's quality thresholds, right? You don't want to go with an asset that has less than 40% confidence score. So we always allow, if you choose to, bring a human in the loop as a part of your workflow. Anything else to add, John?
I think that sounds great.
Are we ready for demoing? All right.
Yeah,
Just like rotate.
rotate this.
Yep.
It's off.
Is it
I-
working?
yeah.
Right. Let's do this way. So awesome. To get started with Bedrock Data Automation is super simple. I'll show you that in the console and then we'll have a bit of fun. I want to just double click on one thing. Hybrid search is awesome. Here we're going to show you how to extract data, but once you have your data, being able to do retrieval that has the right level of accuracy, this is a key solution that a lot of customers will success there. Okay, so let's get into our console. All right. So when you get into AWS, into your AWS console, if you go into our Oregon region, you'll be able to see our Bedrock Data Automation here on the left side. And just like Arnab was saying, Bedrock Data Automation is really here to help you solve real life problems. You have data, it is in documents, it is completely unstructured, and you want to be able to put it into a pipeline that will interact with your users, most probably with generative data. Because right now, everyone wants to interact with natural language. But you want to do the extraction in the easiest way possible. And the best example I'm going to give you there is actually getting started with a document where I know what the content should be, but I don't know what the structure of the document is going to be. And one of the examples I'm going to have in mind is I'm going to use my resume. Here. And we're going to run it through what Arnab was describing at first, which is plain like output. So here we're going to generate results there, and you'll see that out of the box, it's going to give me a structured output, but in this case, it's just going to give me format. And by default, it gives me a markdown format of my document. You're going to see it out there, and it's really great. It's a great first point because I can use that formatting for chunking. How many of you are doing advanced strategies for chunking on your retrieval of generation? Yes, 2. Awesome. If you have Markdown, you can do hierarchical chunking, which is super useful to get a better level of retrieval. But you can see here that I can do text with Markdown, super easy. I can do CSV tables. So if I only have data that is tabular in my source, then I'll be able to extract that in a CSV format. Super easy to use. And here it gives me that. So you can see all of the information has been extracted, and I can just feed that into a retrieval augmented generation pipeline. and a vector store is like Milvus, and it's going to work great. However, in use cases like Arnab was describing before, I'm doing a claims management application. I want to have normalization of fields. I don't just want to have the raw data extraction. I want to make sure that I have specific fields with specific names that my application can just put in on, and I'll get a better application. So to do that, we've created custom. I'm struggling a bit with Zoom, but it should be all fine. We're going to create a custom output blueprint. And that's where Bedrock Data Automation becomes really interesting. So here, it's going to be resume demo number 4, because I've run that before. But here you can see that I uploaded my document, and I have a natural language field where I'm going to describe the extractions that I want to do. And because I don't want you to see me typing all night and making mistakes, I prepared that here. So here I'm describing the document. I'm saying, well, this is going to be a resume. It has the name, it has the email address, it has the education from my user, it has languages, it has all of that. I want to describe all of that in a template, in a blueprint, that will then be used to extract, regardless of the format of the document. So if you give me your resume and the information is there, then VDA is going to give you the extraction.
I was just going to say, this is advanced prompting. You don't have to be a prompt engineer to be able to do that. That's another thing that we keep getting feedback is with the proliferation of models and messaging types, etc. How can we make it intuitive for business users just to write natural language text and get the same quality of results? That's what it just showed.
Exactly. And what gives me there? So I just prompted Bedrock to say, hey, here's what I want to get from my document, and created this JSON. It is a JSON. It just shows it to be in a nice way, but it's a JSON. And you can see that I have my field. It is not normalized in my downstream application. I can use that field strictly. And I have my extraction instructions. It looks very much like prompting, just like Arnab was saying. But you don't have to do prompt engineering. We do that for you. And I want to go back to something that Arnab was saying before. We will give you a real confidence score. So I don't know how many of you have been doing multimodal understanding with large language models. Like showing, one, two, or more. Have you struggled with probabilities and confidence? Yes. Okay, I see everyone. It is a real problem. So we really mapped up large language models with traditional language understanding and traditional ML models to actually give you usable confidence scores. I'm going to generate results there so you can see what it looks like. And you'll see that we'll get tables with the extraction of everything that we requested before. And I want to also, I asked also for the model to create an inference field there. I can ask VDA to say, well, based on all that, I also want to see how many years of experience this person has. And it's going to use the information that it is in the resume to actually infer that information and give that to me as a standard field. It's super interesting to build out. And once I'm done, I can just run that model against many different generated results that I've generated already. So you can see that I worked at this for a long time. And you can see if we go to the second page that I actually worked at in various afterwards. It did all of the extraction. I have a super nice usable table, and I can use that regardless of the format of the resume itself. So this is how we can use custom output to actually do normalization, targeted extraction, without having to go through prompt engineering for each of the fields that we want to extract. And we also give you a super simple 4 cents per page pricing for custom extraction. So regardless of the number of fields that you have there, regardless of the number of pages you have there, you have a very, very simple pricing for that feature. All right. So that's what I wanted to show you in terms of blueprints. The next step is, well, you may be asking, okay, it's great, we can extract data, but what do we do with it afterwards and how we organize that? Well, you can get it into a retrieval augmented generation solution, and you can use the one that you want, the one that makes sense for your particular use case. And in our use case today, what we like to do is use Milvus. So I have logged off. Once I'm logged on, I'll show you exactly how I can do that. But what I've done is basically I've taken a set of documents that are basically description of talks, like the talk we're doing tonight, and I put it into super simple PDF documents. So imagine that someone just says, hey, I'm going to talk to your event, and I'm actually going to send you that to snail mail. For some reason, it's perfectly fine to have actual data ingestion pipelines, but in this case, that's a demonstration that we're going to do it. And here, I'm going to go to Jupyter, and I'm going to show you what the data looks like. Once I've extracted it, it actually looks like Markdown, which makes it super easy for me to just parse through a better run an embedding model. In my case, I'm using the Titan embedding model, and then put it into Milvus for a query. So I've done that. As you can see, I have my data that is available here. I split it, I loaded it, super simple. I use Bedrock to do my embeddings, and then I just inject it into Milvus, and then I can ask specific questions. Did you want to speak at the event? Yes. I can see my speaker application, I can see all of the information, and that was extracted from data I ingested to standard output.
Awesome.
All right, excellent. Do we have any questions?
Sure.
Cover the unstructured data, about 10,000 documents, each with 40 to 50 pages. How fast can you convert that?
That's an interesting question there. Our service is absolutely serverless. So we do have rate limitations into how many documents you can do in parallel. However, we can usually be extremely fast in terms of managing the documents. So we can do that in a matter of minutes. It really depends on how many queries we're doing and how your pipeline is on. Usually when we're doing a call to a specific document, we're going to get back to you in a matter of a few minutes. We don't do real-time seconds. We don't feel that's the right way to manage this. However, in your use case, depending on how you're building the pipeline, you could get that done in a matter of minutes.
Do you think that what can you do it all at the same time?
No, we can do that all at the same time. What I'm saying is, we don't consider this to be a great use case for a super synchronous, hey, I send you this image, I want to have that answer in a matter of milliseconds. No, that's not what we're building out. We're building document pipeline, so we're talking minutes, not seconds. However, we can talk millions of documents. So if you're telling us you have millions of documents you want to process, we can do that super well. We do have quotas, which is the number of jobs that we have in parallel that can be run, and we can adapt that based on how much you want to do, but we absolutely can look with it.
Are you using Nova models for referencing?
That is an excellent question. So considering this is a managed service, we do not disclose the model we are using on the back end because we want to make sure that we can use the best models. However, if you look at the new Nova models, you'll see that they have very deep PDF and image and audio and video understanding capabilities that would make them a very good target. That's all I'm going to say on that topic.
I saw another raised hand. Yeah, go ahead.
Talking about data intelligence, right? But then also start with like data and put into your pipeline. You help with that as well, like finding the right documents to then ingest to your pipeline, or you always want to?
I'll take a shot, then you can answer. But yeah, getting the right data to ingest in Bedrock Data Automation, I'm not sure if we support that through Bedrock Data Automation, but we have other ways to do that. So it really depends on the use case and the type of errors that you're seeing when these large documents are there that you feel that are not applicable to be there. But I haven't heard. Jean, have you heard of anything?
Usually, I would recommend extract all the data from all the documents you have and do your filtering afterwards.
Yeah.
We usually have the various same steps. You extract, you classify, you enrich, and then you use. I would do the filtering that you're talking about at the usage part at the end of the pipeline.
Super expensive.
It-
Might be good for AWS.
Yeah, data curation is a very, very complex topic, right? And even for inference, that's a tremendously complex topic. So again, like I said, I don't have a straight answer for you, but given your use case, there are opportunities we can use to help with the curating of the data before you send it for inference.
And our objective is to make sure that you're successful, not that we make you infer more. Reach out to your AWS team, we can optimize. I think we're
We're out of time.
Just
Oh.
if you got this and answer our survey there, we'll actually provide you with a $25 fee discourage to get you started. And feel free to give back on the old event there. We'll put other QR codes.
Yeah, thanks so much, Arnab and Sean. I really like the system that sort of, I love the design, makes it look so easy to take advantage of, so everyone, let's give them a round of applause. And now I wanted to introduce our third and final speaker for the night to the podium. So Anushrut Gupta from Hasura.
Thank you.
And, this one.
I think I'll leave that. Yeah.
Okay, do you want to stop sharing your screen?
Did already.
Oh, you did, okay.
Thank you.
Okay. And so you got the lavalier. Yeah, that's good. Cool.
Hello. No.
Need to push this.
There you go.
Hello. Okay. Let's do this. Coming up. Awesome. Hey folks, I am a construction worker. No, I am Anushrut. I'm the product lead for this product called PromptQL. We saw some incredible demos with how to prepare your data, right? How to extract structured information from a bunch of unstructured data. Great demo by Bedrock. We also have these incredible vector databases like Milvus with their incredible semantic search, lexical search, and hybrid search capabilities. But what's next? How do you connect these databases, these different data formats to your AI? Most people will say RAG, right? Basically, take this data and give it to the LLM. That's what I'm here to question. Whether RAG is the right way to do it. Can you really achieve 100% accuracy on real enterprise data using a system like RAG? Basically, using in-context methods where you take the data and give it to the LLM. Enterprise data can span from structured data in SQL databases, NoSQL databases, coming from microservices and APIs, coming from SaaS applications, and then, of course, unstructured data, which you keep in vector databases. So let's look at an AI system. We are a Series C company. We are trying towards 100% accuracy. This is much bigger than a Series C company. This is a $2 trillion company called Google, which has an incredible assistant called Gemini, but it does not work. So what I asked Gemini on Gmail, how much have I spent on Uber in 2024? It said that you have spent $176 on Uber Eats. And I'm like, no, can you tell me about Uber trips? It says $73 on Uber trips. So I asked it, how did you get this response? You can see just in the month of December, I have like 30 Uber receipts, right? That's sad, but I have 30 Uber. I also own a car, but kind of fun. But I asked it, how did you get this response? It says that I found an email containing an Uber receipt dated January 23. Also, I found emails containing Uber receipts dated April and December. Adding these three together, I get this amount. I have easily 100 Uber receipts. And I'm sure there's a RAG system under the hood. They have the best vector database under the hood. They have the best infra under the hood, best LLM under the hood. This is the performance. So my question to you is, why do you think Gemini does not work? Who can answer why I got this answer wrong? Oh, by the way, if it wasn't obvious, it's not accurate. Big answer. I completely agree with that. But this is the realistic user query, right? Like their product managers would have expected users to ask such a question, right? But they didn't prepare for it. Okay. So the problem is with how we connect data to AI systems. And RAG is this biggest thing. And one of the biggest RAG benchmarks is called frames. Has anyone heard of frames benchmark? You've heard of frames benchmark. Nice. So frames is a benchmark by Google. Surprise, surprise. And it is basically a benchmark on Wikipedia articles with very complicated questions. Like 824 challenging multi-hop questions where you need to answer that question. You have to look at multiple Wikipedia articles to come up with the answer. And questions are very convoluted, right? Like they are something like this. They got the first question. If my future wife has the same name as the 15th same first name as the 15th First Lady of the United States, mother, and her surname is the same as the second assassinated president's mother's maiden name, what is my future wife's name? Right? Convoluted question. Cannot find it in one Wikipedia article. You have to look at least 4 Wikipedia articles to answer that question. And a typical RAG system with a Claude 3.5 sonnet gives you completely wrong answers on something like that. And those are the expected right answers. Even DeepSeek Carbon recently launched their own accuracy numbers on the frames benchmark, and they have been able to reach an 82.5% accuracy. Now, looking at the different RAG systems, right? A naive RAG is basically a single semantic search, find the top N articles, give it to the LLM, ask it to answer the question. Agentic RAG is basically you let the LLM call the semantic search function multiple times. That based on the first article you saw, you might want to search for more articles. User-given plan is basically I as the user prompt that, hey, first look for this kind of an article, then look for that kind of an article, and then come up with an answer. It improves the accuracy. Can we get to 100%, right? For such convoluted questions. So let me try that question and see what a system which is actually smart looks like. Same question, if my future wife, I hope it works. I made a big claim. So I asked a question like, the same question. If my future wife makes this bigger. So look at what the system is trying to do. It says let me break this down into steps to find your future wife's name. First, let's find who the 15th first lady is and then find her mother's first name. The right first step, that's what you would do as a human being. I'll search Wikipedia articles about the 15th first lady, and then I will extract information about what her mother's name is. And it's implementing an agent on the fly, executing that agent on the fly, slowly for some reason, and we'll come up with the answers soon. Let's see what's happening. Okay, I'm gonna refresh this page. Start a new thread. I hope it works. As I have a saved thread, so that should be fine. Okay. Deterministic, doing the same thing again. That's great. Implementing that agent, executing that agent. Okay, nice. I see the Harriet Lane was the first lady. Great. Now let's search information about her mother. Great. Right. Next step. You might be asking, like, how important is speed versus accuracy, right? That's a perfectly fair question. Because this is not an instant AI response that I expect. But in enterprise use cases with enterprise data, I am willing to trade speed for 100% accuracy. It says that now that we know the first name is Jane, let's find out the maiden name of the second assassinated president's mother. Let's figure that out. Create an agent specifically to find this information, implement that agent, execute that agent, and based on the information, the answer, therefore, your wife's name would be Jane Malha. That's what was expected from the frames benchmark. Actually, the first question is Jane Malha. Okay, you see how you can implement. This is a 100% accurate AI system on unstructured data. Huge claim. Now, let me explain to you why I was able to build this. How was I able to get to 100% accuracy? And that's what we got from PromptQL. So basically, the problem is with in-context data retrieval and processing. All your RAG systems, your tool calling systems, your multi-agent systems, what they're basically doing is, you might have the most efficient way of preparing data like Bedrock. You might have the best vector database like Milvus. But the problem arises when you connect these incredible systems to your LLM by just fetching that data and handing over the data to the LLM. LLM cannot handle data, right? LLMs cannot handle data. And the problem is with the in-context processing of data. So this is, if you want to take a screenshot, I won't spend a lot of time on this slide, but this is basically all these different approaches, RAG, tool calling, text to SQL, multi-agents, they lack one of these capabilities. Inability to access data from any kind of data source, inability to perform computational logic, inability to, they're heavily limited by their own context windows. Enterprise data is huge. What if I want to do an analysis over a billion rows of data? How do I use a simple RAG system or a tool calling system or an agentic system to do that? Multi-step query planning, what I just showed you. And then self-healing. It did not mess up, but if it would have messed up, like how does it understand it messed up and self-heal itself, right? That's what we want to do. So LLMs are great at planning. Just ask it, how would you have solved this problem if you were a human being? Don't do it, just tell them, right? They'll give you a very good answer. LLMs are really good at planning. LLMs are bad at processing large amount of data in its own context. That's what you want to separate out. And that's basically what will help you answer a question like this. Like imagine an AI system, right? On structured data and unstructured data. A question like find tickets, like a typical customer support assistant for my internal teams. Find tickets raised over the last 7 days by enterprise customers regarding service timeouts where an SLA was not met. Identify whether they were satisfactorily resolved and issue $100 in credits to the users it wasn't. So tickets are coming from an unstructured database, but I need to, like on the metadata, I need to put a structured filter by enterprise customers, right? What plan my customers are on, they're in a structured database, that's a big query. Regarding service timeouts, so it's an unstructured query, I have to look inside the tickets to figure out if that ticket is about service timeouts, where SLA was not met. So I need to do this kind of a calculation that when was the ticket created, when was the ticket closed, what was the delta, what was the SLA promised, did it meet that or not? And then identify whether they were satisfactorily resolved. So you need to understand the entire ticket interaction between the customer support agent and the customer and see whether it was satisfactorily resolved or not, and issue $100 in credits if it wasn't a satisfactory resolved. So basically call an API, right? And I tried building the system with all the latest and greatest models connected to an unstructured database, connected like RAG, connected to a structured database through tool calling, connected to an API tool calling, and gave it a Python runtime as well. Like someone said, right? Like they are not good at math. So gave it a Python runtime. So do your computation in the Python runtime. Don't use your own brain. This is the result I was able to achieve with real enterprise data, our own enterprise data. This is the result I was able to achieve with all these top of the line models. But then I took this idea of separating planning and execution, right? Where LLMs are great at planning, not good at execution, not good at handling data. And if I ask you, right, you all are engineers, many of you are engineers, to solve one specific user query, can you just write a program to solve that query? Forget about AI. Can you write a deterministic program to solve that one query? You can, right? For 2 queries, you can, 3 queries, you can, but if given a free-form text box, the user can ask whatever they want, right? But what if you could have a very task-specific agent? And when I say agent, I mean a programmatic agent on the fly, which is 100% accurate for that specific task, and execute that deterministically outside of the LLM's context. You can achieve 100% accuracy on any query on any kind of data. And that's what the idea behind PromptQL is. Basically, PromptQL separates query planning from with query execution and implements task-specific agents on the fly, as you were seeing when I asked that question. And it is backed by Hasura's data access layer so that you don't have to write separate data access pipelines, so like a tool calling pipeline or a RAG pipeline or a like multi-agent orchestrator, stuff like that. No, just a single way to access any kind of data that is connected to a single access layer. The LLM has just one way to fetch data from that. So let's see PromptQL again, but this time for like a much more complicated query. And hopefully it goes faster this time. So I'm going to refresh this again. And now this is that typical internal customer support kind of question. So I want to know how many unique organizations I as an enterprise SaaS company serve, right? But my organization data is messed up. So I want to find unique organizations. So maybe looking at the individual users I have, every organization has some users. Every user has a bunch of projects with us. I want to find the number of unique organizations I serve based on the user details. And then for each unique organizations, tell me how many users they have, how many projects across all of their users, total billing across all projects of that org, and total support tickets across all their users. Data coming from Zendesk, unstructured data in Zendesk, support tickets, structured data in Postgres, sorry, about my product usage. So what PromptQL is doing is coming up with this query plan. This, I'm so sorry, task specific agent on the fly. It says that I'll find out unique orgs based on the email domains and then find all of this information, give you all of that information. It implements that agent, executes that agent, and gives me a list of all my unique orgs that I serve. You see how it was able to perform a complicated query on multiple data domains 100% accurately. If I write this question again, it will give me the exact same response again. I have also the capability to edit this AI's brain. I can click on the tiny edit button and I can basically say that, hey, don't do step 3. Do this instead of step 3. You should add a step 4, right? I can edit my AI's brain and it will just follow my command, but just in the interest of time, I'm not going to do that. Let me ask a follow-up question. Okay. Follow-up question, like for the organization with the third most tickets here, okay? Third most tickets will be Harrington.com. Find which users individually create the most tickets. Okay. Now, intentionally, I'm doing this third most ticket because I do not want my AI to remember everything, right? That's where hallucinations start to happen. I want my AI to figure out based on the previous results that which is the third most here, right? What PromptQL is basically doing here, if you look at it, it does not try to remember. It says that get the existing artifact and sort by ticket count, and then in that I'll figure the third user. Right? So that memory artifact that you see on the right is not just for you to see, but it's also for your AI to consume in its deterministic runtime. So that no matter what scale of data you're operating with, you can ask follow-up questions. There is no hallucination. So it says that Perez Brown had the third most tickets, and Jonathan, okay. So now I can say here, I can ask a follow-up question, more unstructured data, and complicated question like this. Okay, I want to see whether I'm going to lose this customer, right? Whether am I going to lose this user? So for this user, fetch the details of all their tickets, including the comments, the back and forth on those tickets. Then summarize each ticket thread and show me just the ticket ID, subject, and summaries. And then combine any other relevant metric about this user, product usage, and stuff like that, including the summaries of these tickets, and extract this user's risk of churn. And what is going well, what's not going well, what we can do better. Really complicated question, right? Let's see what PromptQL does. So PromptQL is like, okay, Jonathan again, which is the first one, get all the tickets for each ticket. Have you ever seen an AI run a loop? For each ticket, get all comments in chronological order, combine ticket description, and then use AI to summarize each ticket thread. This is where I call back the Gemini question. What? Okay. This is where I call back the Gemini question, where basically, if Gemini was able to go through each email after putting its Uber receipt search, and then just inside each email, take out the amount, the receipt amount, and then just sum it up in a programmatic way, it would have been able to do what PromptQL is doing here. That's a great thing that it messed up. It's going to fix itself, heal itself, and then re-implement whatever the issue was and execute this. But I am hearing I'm out of time, so I'll let this continue. On the side, I'll keep it open here and not hide the mistakes. And I'll just put the QR code there. Try out PromptQL, build an AI assistant, which is 100% accurate, which just works, and see what you can do with PromptQL. Okay. Thank you.
Yeah, thanks so much. Looking forward to trying it out. Maybe we could arrange some free credits. Next race.
Oh, so it's an LLM agnostic system. You bring your LLM, but Husserl gives you $10 worth of LLM credits to just start building yourself. But it's your LLM, your data. We are just that tooling between your LLM, your data, no matter what kind of data, no matter what scale of data. So.
Got it, got it. So I think we've got time for just one question. So.
Say again.
I did tool former. How's it different?
Tool former?
Tool former.
Like I'm assuming you're talking about tool calling, like function calling? Oh yeah, great question. So basically, what happens with function calling is, your LLM calls some function that's connected to it, pulls the data into its own LLM context, right? That's where the hallucinations start to happen. That's where you hit context windows. PromptQL calls the function inside the programmatic runtime. So it's fetching data inside a programmatic runtime. Now it can be any scale of data. I can process that data inside a programmatic runtime. The LLM itself has never seen the data. So that's why I can scale up my questions to or my data to any scale. Thank you so much.
Yeah, thanks again. So, well, geez, I'm feeling a bit sad now because we're past the talk, the speech part of tonight. And so we're going to do a bit of networking until 8. The Zilliz team will have like a office hours type booth set up. So if you want to come across to us, if you're building with Milvus, this is your chance to get some good technical assistance. I also wanted to mention, so if you could fill out the AWS survey for the event, they really appreciate it. We'll get the QR code back up on the screen. But thanks, I'll just say a few thanks. So thanks to everyone for coming. Obviously, we couldn't do it without you. And thanks to our wonderful speakers tonight. And really grateful to AWS for providing this really fantastic venue. It's a really great space. So appreciate it a lot. So I hope to see you at our next meetup in March, where we'll have Zilliz plus OpenAI, and we'll be building agents. So has everyone here heard of agents? Yeah. Just kidding. Okay, thanks everyone.
It was very easy to digest for non-sophisticated user. Appreciate that.
Yeah, no worries.
Quick question for you. You mentioned that you do a podcast.
Yep.
How often do you release episodes?
A couple a month.
Okay,
I think we're sort of working that out ourselves.
I see. That's very cool. I myself am kicking off sort of like a tech show on Teapot Twitter.
Yeah.
And we'd love to have you as a guest. If you don't mind appearing, we interview all kinds of people in tech and sort of giving advice to newer folk how to.
Oh, thanks.
That is very popular.
Yeah, no. Oh, okay. Well, I'm just gonna. Geez, looks like we can get the QR code, but I'm gonna set up our office hour bench,
Okay.
and
This way.
oh, it's
This
here.
is-
Oh, here it is. Here
Yeah.
it is.
Do your office hours?
Yep, let's do it. Let's do the thing.
If I may get your email.
Oh yeah. Well, actually,
Send you an invitation.
LinkedIn would be great. It's probably the easiest thing.
Okay.
So I can just
Yeah, I already added you on LinkedIn, I think.
Oh,
I think
you
I
did?
just
Can I
got your
take this?
Yeah,
real
yeah,
quick?
just
I
take it.
wanna